Welcome, athletes, to this lesson 3.3 differentiation rules. This time we're talking about the product and quotient rules. So we talked about the power rule last time, and then in class we talked about what happens if you have a negative exponent. We also talked about what happens if you have a radical, because remember that radicals can be converted to exponential form, and then the power rule works with them, right? Even though they're fractions, and or even if they're negatives, we can do the same operations, right? We can multiply them by the coefficient in the front, and we can subtract one from the exponent. So that'll be something that you'll see, again and again throughout our course. We'll use the power rule quite a bit. All right, so now for the product rule. The product rule is what happens when we have two functions that we're multiplying together. What happens if we take the derivative of them? That's what we're trying to figure out. And it's not as simple as just saying, oh, well, it's f prime times g prime. It's not that simple. There's actually a formula for it. Okay, it's actually f prime g plus g prime f. Okay, so if we take the derivative of a function that is a product of two other functions, in this case is j prime. J is a product of j of x is a product of f of x and g of x. J prime, the derivative of that would be f primed of x times g of x plus g primed of x times f of x. Okay, so f prime g plus g prime f. All right, and so this means the same thing here, just with the Leibniz notation. So it's the derivative of the first times the second plus the derivative of the second times the first, right? And when I say first and second, here's the first function, here's the second function. All right, so that's our formula. So remember that. All right, so let's apply our product rule and see how it works in an example here. So here, once again, we have j primed of x. It's f of x times g of x. And we want to find j primed at 2, right? So first of all, let's write out j prime. So if this is j of x, j primed of x based on our product rule is going to be f prime g, right? F primed of x times g of x plus g primed of x times f of x. Okay. All right, and by the way, the commutative property applies here, so there's a lot of different ways you can write this. Like, actually, the way I remember it is I remember f prime g plus f g prime. That's actually the way that I remember it. But yeah, whatever makes sense to you is fine with me. I'll leave that up there. All right, and so I'll stay consistent with the book as we go through these examples. So here I have this all laid out, right? And so now I want to find j primed at 2. And so what I'm going to do is I'm just going to put a 2 in here, and that's going to make all these x's turn to 2 as well, right? Okay. And luckily they give us all those values, right? They give us f of 2, f primed at 2, g of 2, and g primed at 2, right? So I'm just going to plug those in. So f primed at 2 is negative 4. So I'm going to put a negative 4 here. Okay, times g of 2, which is 1. So I'm going to put a 1 in here. Plus g primed of 2 is next, right? And that equals 6. And then finally f of 2 equals 3. Right, and so now it's just some computation. So negative 4 times 1 is negative 4. 6 times 3 is 18. Negative 4 plus 18 is positive 14. So that's what j primed at 2 is equal to. All right. So that's how we can apply the product rule. All right. So here, let's try it with some polynomials. So now we're gonna where our answer is going to be j primed of x as a function rather than the actual value at a certain point, right? The actual numerical value. So first of all, I'm going to find j primed of x. So j primed of x, remember, is if this is f prime, or excuse me, if this is f of x and this is g of x, then remember it's f prime g, and I'll just use f prime and leave the x out for now. So we'll say f prime g plus g primed f, right? Okay. So let's find f and g prime. So f prime, so we know this is regular f of x, right? F prime is going to be the derivative of that, which is just 2x. The derivative of 2 is 0, so that goes away, and the derivative of x squared is 2x. And then g prime is equal to the derivative of this, right? So 3 times 3 is 9x squared, take away 1 from the exponent, and then the derivative of negative 5x is just negative 5, okay? So let's plug those values in. So f prime, right, that's here. I'm going to use this, right? I'm going to plug in 2x. So it's going to be 2x times g, which is this function here, right? That's g. And so I'm going to put that in here. 3x cubed minus 5x. Okay? And then plus, and now I need g prime, which is this. Okay? And then times f, which is this. Okay? So that's it. And that's really, the answer. So now it's just a matter of simplifying, doing a little bit of algebra here. So I'm going to distribute. So it's going to be 2x times 3x cubed is going to be 6x to the fourth. 2x times negative 5x is negative 10x squared. And then we'll distribute here. Okay, foiling. So 9x squared times x squared is going to be 9x to the fourth. 9x squared times 2x is going to be 18x squared. Negative 5 times x squared is negative 5x squared. And negative 5 times 2 is negative 10. All right, so now let's see if we have any like terms. So I have a fourth, x to the fourth here and here. So it's going to be 15x to the fourth. Okay, and then we have a few x squareds, right? One here, one here, one here. So negative 10 plus 18 is 8. And minus 5 is 3x squared, right? And then finally we have this negative 10 that doesn't have any like terms, so it's just going to come down. And so this is what j prime of x is. All right, so that's how we find, or that's how we use the product rule with polynomials, right? In this case, binomials.